Hi everyone, this is 2.1 on functions. A function, remember, is that every x value has exactly one y value. Okay? So if you want to think about it like this, if x is your input, then y is your output. Okay? Or visually, what we can think about, or how you can think about this, is this house is a function house. So if I have f of x equals 3x minus 2, right? And x value goes into this house, right, where it's 3x minus 2, and it's something, a y value comes out, right? So if I wanted to get f of 3, let's say for example, I wanted to get f of 3, right? I would plug in 3 into here, and it would be 3 times 3 minus 2, right? So that's 9 minus 2, that's 7. So a 7 pops out. Okay? So f of 3 equals 7. Does that make sense? Yeah? So that's kind of like visually what we're doing here. Okay? So an example of this would be, hey, look, if I have f of x equals 3x squared plus x minus 5, find f of negative 2. Okay? We would literally just plug in negative 2 for my x values, right? 3x squared, so 3 times negative 2 squared plus x plus negative 2 minus 5 minus 5. And then we just simplify this, okay, using the order of operations. So this would be 3 times 2, negative 2 squared is 4, plus minus negative, or plus negative 2 is minus 2 minus 5. Okay? So 3 times 4 is 12, minus 2 minus 5. 12 minus 2 minus 5, that is 5. So there are multiple ways of representing this. Okay? The first way we can represent this is through this is what we did up here with the visualization. F of negative 2 equals 5, right? This is also a coordinate. Negative 2 comma 5. Okay? So both of these guys work. All right? Questions on that? So just moving forward a little bit, another example. What if I want to get f of 0? All the x's go to zeros, right? But before we do this, anyone can tell me graphically what f of 0 would be? It's a vertical line on the x-axis going up, yeah, but what is f of 0 if I plotted this with this graph. If I graph this function, what would f of 0 be?
-5.
Oh yeah, it would be -5 because everything else would be 0, right?
Yeah.
So the math behind it, yes, it is pretty simple, right? That would just be a big fat 0. This would be a big fat 0. This is a big fat 0 minus 5. So f of 0 equals -5. Cool. This point is 0, comma -5. Right? What is this point graphically? 0, comma 5, -5, yeah. But what is it called? Yeah, it's a y-intercept.
Oh.
Yeah. So whenever you're getting f of 0 of something, whatever it is, this is your y-intercept. Okay. All right. Questions on that? Pretty simple, right? Remember a function, every x value has exactly one y value. If an x value has two y values, it's not a function. Okay, let's think about that for a little bit, okay? Before we go on to the next part. If I graph this, right? Every x value needs one y value, right? Exactly one y value. So if I take my pen and I scan my graph, let's say the graph looks like this, right? And if I take my pen and I scan my graph, what am I doing? What test am I performing here? The vertical line test, right? And that is a test to test if whether or not a function is actually a function. Or, yeah, a picture or graphically speaking, right? This graph is a function. What if, why does this work? Anyone can explain to me why this works? Why am I holding my graph, my pen vertically and I'm scanning through it? And if at any point it hits my pen more than once, it's not a function. Okay? It's like going through a metal detector, right? If it hits it more than once, it's not a function. Why does that work?
Because you're trying to see if one x value goes to like more than one value.
Yeah. Because if it does hit more than once on this vertical line, right? You know that the vertical line, I'm just changing my x values, right? Here it might be -10, -9, -8, -7, -6, so on and so forth. X equals 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I'm just changing my x values as I move from left to right with my pen. Yeah. And I'm checking that at every x value, there's exactly one y value. Okay? That makes sense? So if I say, hey, look, this is my graph now. At this point, I'm going to make another point right here, right? That's a part of my graph. At this point, it hits it twice, right? So let's say at, I don't know, x equals 4, right? Let's say that that's 4. It has two values, right? One up here at 5 and one down here at -5, right? Yeah. So therefore, since this x value has two y values, it's not a function. That make sense? Okay. I just wanted to talk and define function, what a function really is. Okay. Now moving on to piecewise functions. Okay, that is a function that is broken up into parts via the x coordinate or your domain. Okay? A function that is broken up into parts via your x coordinate or your domain. All right, what I mean by that is f of x, which is the function notation, right, equals, and there are parts to this. Okay, if it's going to be x squared, if x is less than 0, and it's going to be x plus 1 if x is greater than or equal to 0. Okay? You see how there's two parts? And it's broken up by your domain, right? By your x coordinate. Okay? All right? Let's find all these values. F of -2, f of -1, f of 0, f of 1, and f of 2. Before are we graphing in this section? No, we're not. We're just doing it algebraically. Okay? All right. So f of -2, remember that this number here, the -2, right, is your x value, right, is your x coordinate, right? So we're going to plug in -2 into this one or this one. Really quick, is it number 1 or number 2? Stick up a finger or 2 fingers if you think it's 2. Please don't stick up your middle finger. Flip me off. I'm recording. 1 or 2? Stick it up high so I know, really like a quick check. Yeah. If I wanted to get f of -2, which function would I use? Would I use x squared? Would I plug it into x squared? Or would I plug it into x plus 1? 1 if you think it's x squared, 2 if you think it's x plus 1. 3 if you are confused. And be honest, right? So I know really quick, okay, so I need to explain this more. Yeah. Remember that this, okay, thank you, pen down. Remember that this -2, right? What does that represent? The x value, right? Just like how it's f of x, right? In parentheses, follow the notation. F parentheses x close parentheses, right? F parentheses -2 close parentheses. So it happens that x is equal to -2, right? So that, take that -2, where does that -2 fall? Is it less than 0? Or is it greater than or equal to 0? Which one is it? 1 or 2? It's 1, right? Everybody understand that? That -2 is less than 0, right? So therefore, we use this function, okay? So we kind of read this from right to left, Okay. So just remember that. So -2 squared is 4. -1, since -1 is less than 0, it's the same thing. -1 squared, which is 1. 0 is equal to 0, so then it has to be number 2, right? Which is 0 plus 1, which is 1. 1, which is number 2 because it's greater than 0, is going to be 1 plus 1, which is 2. And then 2, which is greater than 0, is 2 plus 1, which is 3. Okay? Make sense? You are going to have more domains broken out, right? You can have like 5 different equations here with 5 different intervals. Okay? That's the only difference, right, with different equations. But the process is still the same. You got that? Yeah? Okay, we are almost done, guys. Stay with me. The next thing we have to talk about is net change. Okay? Net change is the actual definition is the change in your y value, in your y, when x changes from one value to another. Okay? All right? So if I give you another function, f of x equals 2x minus 1, and I ask you, hey, what is the net change, or find the net change from 1 to 3. Okay? If I ask you to do that, all I'm going to do is find f of 1 and find f of 3. Why don't we take 2 minutes to find f of 1 and f of 3? Okay? Or if you guys went ahead and did f of 1, it would be 2 times 1 minus 1, okay? Which is 2 minus 1, which is 1. So f of 1 is 1, which the coordinate will be 1 comma 1. Okay, f of 3 would equal to 2 times 3 minus 1, which is 6 minus 1, which is 5. So f of 3 equals 5, so it's 3 comma 5, right? So the change in y, the net change is the change in y when x changes from one value to another, right? When x goes from 1 to 3, what's the net change? What's the change in y then? 1 to 5? 4. So your net change is 4. Okay? That is net change. What's the slope? Rise over run? 2. Yeah. When you guys thought about it, I just want to know. When I asked you for the slope, who did the 5 minus 1 over 3 minus 1? Okay. You guys did it algebraically. Who just looked at the equation? Both are correct, right? You can just look at the equation, y equals mx plus b, right? Or get the slope this way. All right. Next idea, and it's a big one, okay? To find the domain of the function, okay? When we are asked for the domain of the function, yeah, it's going to be all real numbers, okay? It's all real numbers unless, so let's write that down. It's all real numbers unless, you guys know this capital R or look like a paragraph, but it's an R instead of a P. Yeah, this is all real numbers. Okay, if you didn't know, just write it out somewhere. It's all real numbers unless, number 1, your x value is in the denominator. Okay. Why that's the case is because your denominator cannot be 0. Okay? Your denominator cannot be 0. So we just got to set it, and we got to figure out what makes it 0, right? And make sure that it does not equal that. Okay? Or 2, there is an x value. Your x value is in a square root. Okay? And this guy, the rule would be no negatives in the square root. Okay? All right? So you just got to make sure that it's all real numbers unless one of these two guys occurs. Okay? Make sense? And you guys can, I'll give you guys some time to write it out. Yeah. We're doing the notes right now. Yeah, I haven't posted anything yet. Okay? Got this? Cool. Now let's talk about some examples to find the domain. Okay, so your example, your directions would be find the domain. Okay. 1 over x minus 3. So since my x value is in my denominator, right? My denominator cannot be 0. So it can be all real numbers except this guy cannot be 0. Except this guy cannot be 0, right? So if I solve for this, x cannot be 3. Correct? So my domain here would be all real numbers except 3. You can write it like that. If I ask you for the interval notation, it will be negative infinity to 3, parentheses, u, 3 to infinity. You guys remember or interval notation? Yeah. Okay. Questions on this guy? All right. Questions on this? Yeah, Tisha.
So what if the numerator like is something else than one, or is it typically usually just one?
Well, it doesn't matter. That numerator doesn't matter because I'm just trying to find a domain, right? And the domain is always going to be all real numbers, except for those two rules that we stated, right? So make sure that it doesn't break those two rules and you're good. Okay. Like the second, let's say x squared minus 3x plus 4. What's your domain here? Is there an x in my denominator? No. Is there an x in the square root? Or any even number root? Square root. The little house with the, look like a check mark with a division. That's the square root, right? There's no square roots, right? So it's all real numbers. That make sense? Yeah. All we're checking are those two scenarios. Okay. So the third one, let's say it's the square root, of x squared minus 9. What's the domain here? X squared minus 9 must be what? Greater than or equal to 0, right? It must be positive or 0. 0 is neither positive nor negative. So just solve it. Add 9. X squared needs to be greater than or equal to 9. X needs to be greater than or equal to positive or negative 3. What does that mean?
That means that it can't be positive or negative 2 or 1. It just can't be any numbers with absolute value less than 3.
Yeah. So this x value, right? If the x value, let's just, instead of me teaching you guys like a robot, let's talk about this. If x squared must be greater than or equal to 9, right? What numbers can it be? X. 9 squared is 81, which is definitely greater than 9. Yeah. It could be, can it be negative 9?
Yeah.
Negative 9 squared is still 81, right? Which is greater than 9. Can it be 2?
No.
2 squared cannot be, right? Can it be 1?
No.
No. 1 squared is 1, right? So it's not greater than 9. Can it be like 2.9? No. So if I jot this down on a number line, what we just did, right? 0, let's say that this is negative 3 and this is 3. It could be equal to 9. So it's equal, so that's why it's closed circles, right? And Sebastian here said it's 9, right, as an example. So it could be this way, or it could be -9, or it could be that way. And we just went over the example of it cannot be 2, or -2, or 2. It cannot be -1 or 1, right? I do not want anything inside here. That make sense? Yeah? So this is an OR graph. So that's your OR series. All right? Questions on that? No? Last one of the day, I promise. Still the same thing, right? Get the domain of this. X to the 4th over x squared plus x minus 6. Okay, try it. Okay, so here, x squared plus x minus 6 cannot equal 0, right? Yeah, because that's the rule. So if I factor this out, you guys remember factoring? Yes. X plus 3, x minus 2. X plus 3 cannot equal 0, or x minus 2 cannot equal 0. So x cannot equal -3, or x cannot equal 2, right? So then this would be all real numbers except for -3 and 2. Or you can say that it's from -infinity to 3, union -3 to 2, union 2 to infinity. In interval notation. Yes?
Or would be -infinity to 3.
Oh, yeah, to -3. Okay? And that is the lesson for 3.1. That's it. Thank you.